A 15-foot ladder rests against a vertical wall, which is perpendicular to the ground. When we set that ladder against the wall, it forms a right triangle with the vertical segment being y, the horizontal x, and then the hypotenuse is the ladder itself, labeled as 15. The top of the ladder starts to slide down the wall at a rate of 2 feet per second. That means dy dt, the rate at which the y value is changing over time, is negative 2 feet per second. Now this must be negative for two reasons. One, the negative implies direction, since the top of the ladder is moving in a downwards direction. And two, the y value is getting smaller over time as the ladder is moving down the wall, so we need that dy dt to be negative. How fast is the bottom of the ladder moving from the base of the wall? That means we are finding dx dt, the rate at which the x value is moving with respect to time away from the wall, when the bottom of the ladder is 9 feet from the wall. Be careful about making use of that. That means the x value is 9. However, you don't want to plug in 9 too soon, since we need to maintain x as a variable. Now that we have a diagram, we labeled all of our information on the diagram, organized all of the important information. Next, we need to make an equation. And whenever you have a right triangle and you're trying to relate the sides, and you have variables, expressions, and important information as sides, try to make use of Pythagorean theorem. That would give us x squared plus y squared equals 15 squared. You can simplify that 15 squared to 225 if you'd like, but I'm going to go ahead and take the derivative of this equation with respect to time t. The derivative of x squared is 2x multiplied by dx dt. There's your implicit differentiation, plus 2y times dy dt. The derivative has to be with respect to time implicitly, and the derivative of 15 squared is 0 because the derivative of any constant is 0. Next, we can try to plug in the information we know into this equation. 2 times x, we can plug in the x value is 9 now because we already took its derivative in the previous step, multiplied by dx dt, and make note that that's what we're trying to find. We don't know that yet. Plus 2 times y, and then when you think about it, we don't have the y value given to us, but we can find it. It's a matter of going back to our diagram, relating the x and the y, and it was all related from this Pythagorean theorem over here. Now we're going to make use of x is 9. At that instant in time when x was 9, we had 9 squared plus y squared, whatever the y value is when the x value is 9, equals 15 squared. This will help us find the y value we need at this instant in time. 81 plus y squared equals 225. And when we subtract the 81, we will have y squared equals 144. Square rooting gives us y equals 12. Don't use the plus or minus 12. We don't want a negative height here as a distance, so we'll just use the positive 12 for the y value. Multiplied by dy dt, we organize that as negative 2 at the beginning. Set that equal to 0. Let's isolate dx dt. 18 multiplied by dx dt minus 4 times 12 is 48. Set that to 0. Isolating dx dt, we can add the 48 and divide the 18. And if we were to reduce, take out a 6 and get 8 over 18 divided by 6 is 3. Feet per second would make your units, and make note that dx dt is positive since the x value is getting larger as the bottom of the ladder moves further and further away from the base of the wall over time.